Okay, so point D from point C. So this will be equal to 2J equal to 6J. K cross I is positive, so minus 0.5 J, 0.5 omega J. So this is equal to minus 8J is equal to minus 0.5 omega J. Omega is equal to 16 radians per second. Whatever you are comfortable, you use. Okay. If you ask me which one I prefer, I think I prefer the vector form. Okay. If geometry are easy to follow. Sometimes if the geometry is like for example, I think this is like a revision. Like for this case, right? It's easier to use what? Instantaneous center. Yes or no? Right? So you make your judgment call. I find like the working for this in instantaneous center is so short. Okay, if you do it long, okay, but you decide. Right. So now we have our omega. Okay. So now we know our omega is 16 radians per second. So next we're going to find AC. Okay. We're going to use AC is equal to AD plus by alpha cross RC from point D minus by omega squared RC from point D. Okay. Now, this case, the next thing we have to do is we have to construct our acceleration vector diagram. Okay. So we are going to focus on acceleration. We are going to focus at point C and point D. Okay. So we know over here, this is our acceleration, which is 2 feet. Now, this is in tangential direction. So this is in 2 feet per second squared. Coming down here, right? So this is AD, tangential, and we are given is moving at 3 feet per second squared. Okay. 3 feet, 2 feet. Okay. So we know that this is the center of rotation. This is our AC in the normal direction. And over here, this is our AD normal direction. If we are going to put the I inside here, this is negative, this is going to be what? Positive. Moving towards the right. Positive, moving to the left. Left is what? Negative. So once we know this, right, we can start doing this diagram, okay? So we know that ACI, we know that positive, you have to be really careful, okay? ACN I, okay? And then this is plus by 2J. Then this will be equal to minus ADN. The trick about doing this problem is make sure you have enough sleep. You got not enough sleep, you are screwed. Trust me. Been there, done that. Plus, now we know that omega is in this direction, okay? I'm going to assume that alpha is also in that direction. That's an assumption. Later on, if wrong, you all know that it will flip around. So alpha, now this is equal to minus alpha k. cross. So we are going to, so point D is our reference C, right? So it's minus 0.5 I, right? Because it's on the left-hand side of D. And then we have minus by 16 squared minus 0.5 I. Okay, so this is our whole expression over here. So we put in A, C, and I plus by 2J. This is equal to minus AD and I minus 3J. Okay. K cross I is positive, negative, negative. So it will be positive 0.5 alpha J minus by 16 times 16. 16 times 16 times 0.5 should be plus by 128 I. Okay. So we look into our J component. So we have 2, and this is equal to minus 3 plus by 0.5 alpha. So 5 is equal to 0.5 alpha. Alpha, so 5 divided by 0.5, we get 10 radians per second squared. So the assumed direction is correct. And then now we do the I component. So the I component, you have AC N, and this will be equal to minus ADN. And this will be plus by 128. Okay. So remember, I wrote a formula regarding acceleration in the normal direction, and this is equal to omega squared r, right? This is equal to omega squared r. Okay. So omega squared over here is equal to how many? Omega is what? 16 squared multiplied by the radius, which is equal to 0.25. So this will be equal to what? 16 times 16 times 5 by 25 is equal to 64. Okay. So if we put this number over here, right, we have AC N plus by ADN, this is equal to what? 128. So now we know this as a what? As a magnitude. Okay. Because later on we need this value to compute our A, B, N. Okay, so this is our point B. Okay. So coming back to the problem, if you look at the solution manual, they have to find on what is going on in point A. Okay. I'm going to ignore it. Okay, we are strictly going to jump. We can now, because if the concept of rigid body is correct, we can relate to where? Any point, yes or no? Hello, is it me? Yeah, I think it's me. Oh yeah. Sorry. Okay, so now we can relate. Hello, it's a connector. Okay, don't touch it. Right? So now we are going to do something that is not normal. I'm okay with that. Some of you realize that I'm not normal also. I know that. In life, what do you need to be? Anyone? Dare to become different. Are we clear? Right? But don't be an ass, okay? When I say dare to become different, it means do things differently, but with common sense. Okay, so now what we're going to do is we're going to find AB is equal to AC plus by alpha cross RB from C minus by omega squared. I'm having a brain fart. RB from C. Okay. So we will have. So if you look at distance wise, right? If we look at distance wise, or I'm going to suggest, I'm going to assume this is my acceleration for point B. Okay, so AB tangential, and then this will go back up AB normal N. Okay, so we know that this is minus in I, and this is plus in J. Okay, so we got that. Now, some of you were asked, Eugene, why ABN in a J is not equal to 64 radians per second squared. Right? Yes. To be frank, I don't know the answer. Okay? So don't assume. Okay? I really don't know the answer for this case. So when I don't know the answer, why I cannot do that, I'm trying to use this equation to show us whether is it going to be what? 64. Okay, now I don't know, really. Okay, and why I cannot use 64, I will also tell you that I don't know. Okay, don't laugh, okay? I'm honest down here. Other prof will bullshit, okay? But I really don't know. Yes. Yeah, you can, or it can be coming downwards, right? Either way, okay? That might be a point down there, okay? Okay, but for now, okay, because of what you just said, okay, maybe later on, what's your name over there? Hey, Brian, because of you, we maybe have to calculate the acceleration at point A. Okay, right? I like that, okay? Because of you, like, he has a point there, okay? I like, yes. No, okay, I don't know yet, okay? But I like his point over there, Brian, right? Ryan, right? He said, let's find the acceleration at point A and then see what happens. I like that, okay? So from here, we are using this is because point B and C are points on a rigid body. Okay. So now we are going for minus AB tangential in the I direction. Okay. Then plus by AB normal in the J direction. This will be equal to AC. So AC for this case is what? 2I, right? Wait, is this AC? Oh, AC, no, not, okay, ACN, you know, we calculated, you get minus 64I, right? Now we have to include the normal and the tangential.